Hello there, math friends. It's time to talk about vocabulary for proportional relationships for Topic 3, our next unit of study. The first thing I want you to do is to take your math notebook, find the next clean page after everything that we've done so far, and I want you to draw 3 columns. We're going to take 3 column notes. The first thing you're going to be putting in at the top of the first column is you're going to write vocabulary term. And then you'll have a spot for the definition of that vocabulary term. And then you're going to have another spot for the visual example. What does it look like? Okay, so make sure that you, when you need to, pause the video so you can write everything down. If it gets highlighted or written in the video, of course, you want to write it down. You're going to copy down all of these notes because you're going to need them for reference for the rest of Topic 3. Okay, so you've got across the top of your notes, vocabulary term, definition, and visual example. So let's get started. Our first vocabulary term is algebraic rule. What is an algebraic rule? Well, it's just a math equation that has 2 variables in this case when we're talking about proportional relationships. And what are variables? Well, they're just letters. And the letters represent numbers that can change from equation to equation or algebraic rule to algebraic rule. And our visual example is right here, y equals 2x. Or you could write it as 2x equals y. They're the exact same thing, they're just reversed on different sides of the equal sign. Algebraic rule. The next vocabulary term is coefficient. Or in this chapter, we're going to call it the constant of proportionality. And what is a coefficient? Well, a coefficient is just a number that is multiplied by a variable. And you know that it's being multiplied by a variable because it's sitting right next to the variable. It's like they're a couple. And so in this case, when we have y equals 2x, the number 2 is the coefficient of x. And we call that also the constant of proportionality. And you'll find out more about that in coming terms and in the next couple of weeks. But in this case, the coefficient of x is 2 because it's being multiplied by x. 2 times x. Our next term is called a constant. Now, a constant is a number that never changes its value. It will always stay the same. Its value will never change. An example of that is if you look at this equation here, y equals 2x plus 1, this 1 that's by itself is a constant. Its value never changes. It's always going to be worth 1. It's not being multiplied by anything or divided by anything. It's just there by itself. If 2x, if that was a couple, the coefficient and the variable, if that's a couple, this would be called the third wheel. It's like the little brother that tags along on a date. That's the constant, and it has an important part too when we talk about proportional relationships. You want to pay attention to the constant, whether it's there or not. All right, well, that leads us to our next vocabulary, and that is, how are we going to find the constant of proportionality? Now you're wondering probably, what is this K that I see here? What does K mean? Well, K is just a shortened abbreviation for constant of proportionality, because you don't want to write that all the time, constant of proportionality. That's a lot to write. You can just call it K. Later on, it could be M. It could be any variable as long as you know that that is the constant of proportionality. And anyway, how do you find that constant of proportionality? Here's how. All you do is find the ratio of the y value over the x value. Remember, a ratio is just a fraction. So if we look at our examples here, we take the y value, we place it over the x value, and divide. The answer to that is the constant of proportionality. So for example, if your y value was 6 and your x value was 3, and you divide those two numbers, 6 divided by 3, you get 2. So that tells us that the constant of proportionality is 2. Our next vocabulary term is a coordinate pair. A coordinate pair. What is that? Well, you've probably seen them before. but it's the exact location of a point on a coordinate grid. And they come in ordered pairs that are surrounded by parentheses, and they always come in XY pairs. The X is always first. So this would be 3, 5 in parentheses. That's a coordinate pair, and that tells you that that point is located at 3 to the right and 5 up on a coordinate grid. The next one is 2, 8, surrounded by parentheses. Coordinate pairs are always surrounded by parentheses. The X is always first, so this tells us that 2, you travel on the x-axis 2 to the right, and then y is 8, you go up 8. And that's the exact location of that coordinate pair. That's a point, location of a point on a grid. Now, you can always tell when you have a proportional linear relationship in 3 different ways. And the thing about proportional linear relationships, the word linear comes from the word line, and so that means it's going to be traveling in a straight line, and it's a relationship between 2 values, the y and the x. Now, how do you find if you have a proportional linear relationship? Well, it's when you take these ratios and divide. So ratios, or fractions, when divided, will equal the same amount every time for every xy pair. When you divide y by x, you will get the same value every time. So, for example, if you looked at something and you divide, and the y was 3, and the x was 6, and you divide them, you get 0.5. If you look at another place and it's 4 is the y and 8 is the x, y divided by x, you get 0.5. Because it happens every time, you know that is the constant of proportionality, and that is your, then you have a proportional linear relationship. So if you look at an equation like this, y equals 0.5x, or 0.5x equals y, if you have the coefficient here that is multiplied by the variable x, and nothing else added or subtracted to it, you have a proportional linear equation. Okay? Again, you have to have just a number being multiplied by x equaling y, and you have a proportional linear relationship in the equation. Now, if you want to find if you have a proportional linear relationship from a table of values, the first thing you need to do is look at your table, and then you're going to set up a ratio of y over x, y over x. And then the second thing you do is divide. Y divided by x, your y value divided by your x value. And then if all the answers are the same, you have a proportional linear relationship. But every answer has to be the same for your y divided by x. And here's our example. Here's our table. X, y. X is 1, y is 3, x is 2, y is 6, x is 3, y is 9, x is 4, y is 12. If you divide y by x in each pair, y divided by x, 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. 12 divided by 4 is 3. We get the same answer every time when we divide y by x, and so we know there is a proportional linear equation. What's the constant of proportionality? Well, it's 3. 3, 3, 3, 3, because that's the number you get when you divide y by x. If you're looking at a graph, here's how we tell if you have a proportional linear relationship when you're looking at a line on a graph. First of all, in order for it to be a proportional linear relationship, it has to be a straight line. Here's a straight line, and that line has to pass through the origin at 0, 0. So it has to pass right through here at 0, 0 on the graph. If it passes through that point and it's a straight line, you know there is a proportional linear relationship between your x and your y. Now, if you can have a proportional linear relationship, that means that there are times when it will not be a proportional linear relationship. That would be a non-proportional linear relationship. That means it's not going to be proportional between y and x. If you're looking at a graph, that line will not go through the origin, or it won't have a straight line. Those are your two, when you're looking at a graph, those are the two cases when you know you do not have a proportional relationship. If you're looking at a table, or a graph for that matter, when you divide y by x, and you do not get the same answer every time, it will not be proportional. And if you're looking at an equation, if the equation has a third wheel, it has that little brother tagging along, you know it's not going to be proportional. Let me show you some examples. So, on our graph, we can see that this line, while it is fairly straight, it does not pass through the origin. It passes through the y-axis at 2. So that's not proportional. It doesn't pass through the origin down here at 0, 0 in the corner. When you look at the table, when you divide these y by x, 5 divided by 2 is 2.5. 6 divided by 3 is 2. 7 divided by 4 is 1.75. I do not get the same answer every time, so it is not a proportional relationship between the y and the x values in the table. And then when you look at an equation, if you see something being added or being subtracted, that's that third wheel we're talking about. It can't be there. If that's there, if something is being added or subtracted, you do not have a proportional relationship. It has to be just the y equals 2x or y equals 3x. All you can have is the constant of proportionality multiplied by your x value. That's it. That's all you can have for those. So now, you've got some questions you're going to need to answer at the end of this. Let me see if I can drag this down for you. So, how do you identify if two quantities are in a proportional relationship by looking at a graph or a table? You need to answer that question. We just went over it up here. From a graph or a table, how do you know if you are looking at a proportional relationship? You need to write that down in a sentence. And then the second question is, you need to explain how you would use the values of x and y to find a proportional relationship. Here's your hint. You got to use the setup. Here's the setup, the ratio of y over x. How would you use x and y to find a proportional relationship? All right, that's it. That's all my time. Have a great day, and don't forget to be awesome.